Okay, welcome back. Let's go ahead and do these next two, just because sometimes these parametric equations are a little tricky, and just so you can see other types. Because these equations, they can involve in any type of function that you've seen. So e's, logarithms, trig functions, radicals, absolute value, any function that we've ever seen in this class, which is a lot, are fair game with these. So you got to remember how they work. So let's look at part C with these exponentials. So we got to solve for x, or sorry, solve for t. So I need to get rid of the e. So I'm taking this equation and I'm going to take the natural log of both sides. So I have ln of x, not ln times x, ln of x equals, and then ln of e to the t, the ln and the e, they cancel out. So I'm left with the t. So now I know what t equals, and I can plug it in for t. So y is going to equal e to the negative ln of x. Well, I can't just leave it like this. I can actually kind of simplify it down. Because if I move this negative, I can move it up and make it the exponent of the x. And now that I've moved it, now the e and the ln can cancel out. I'm left with just x to the negative first, which is really just 1 over x. Okay, so 1 over x typically looks like that. It's those two pieces with a horizontal and vertical asymptote both at 0. But we kind of have to look at our functions here. If you start plugging in numbers for t, is it ever going to come out as a negative result? And the answer is no. If you plug a number up into an exponent, it can't make this base come out as a negative unless it already had a negative on it. So we know that x has to be greater than 0, and same thing for the y. If you start plugging in numbers for t here, it has a negative exponent on it, which makes it a fraction, but it does not make it a negative number. So the y is also going to be positive. So when we go to this graph, we can't have this piece down here because that's where x is negative and where y is negative. It kind of contradicts both of them. So when we graph it, we can only use this section up in the top. Still has a horizontal and vertical asymptotes though, but we can't include the part that's down in the third quadrant. All right, so now for your orientation. So as t gets bigger and bigger and bigger, x is going to get bigger and bigger and bigger. So x is moving off to the right. So draw your arrows in there so that you would be headed off to the right. All right, well, let's try part D. So it's these two trig functions, and t is just going between 0 and 2 pi. So again, why is this here? Well, because remember, trig functions are cyclic, and they start to repeat their values over and over and over again. So this would just restrict it to just rotating around the unit circle just once. So you don't have to keep rotating around and around and around and around. All right, so we got to find an equation with just x's and y's. So this one we're going to take a different approach. We're going to solve, instead of for t, we're going to solve this for cosine of t. And we're actually going to do kind of the same thing over here on the other equation. We're going to solve for sine of t. And the reason why I want to do that is because I know a little famous identity that uses both cosine and sine together. Cosine squared of t plus sine squared of t, what does that equal? It equals 1. So I'm using that Pythagorean identity, and now I can just plug in x over 2 for cosine and y over 3 for the sine, as long as I square them both. So that would be x squared over 4 plus y squared over 9 is equal to 1. And we just saw equations like this from section 10.3. This is the equation of an ellipse. So center at 0, 0, up by 3, down by 3, and left and right both by 2. So now you need your orientation. So it's rotating from just 0 all the way around to 2 pi. Well, if you start plugging in values for t on either one of them, it's going to rotate in the counterclockwise direction. Like x, as t increases, x is going to start to decrease until it hits pi, and then it's going to start to increase all the way back around. Okay, so that gives you a pretty good idea of how these parametric equations work with some different types of functions. So we've got one more video for you, and that'll round out the section and then also conclude the chapter.